The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, all about the BITX40 transceiver. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is brought to you by Elecraft, makers of high-performance radios, amplifiers, and other great station accessories. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design tools, the software we use to design all of our Workbench build projects. For more info and your free copy of Eagle, go to www.autodesk.com/Eagle today.
Welcome to the Ham Radio 360 Workbench podcast, your bi-weekly deep dive on technical and maker topics of interest to the radio amateur. This week, we are joined by our friend, Mark Smith, KR6ZY, crazy with a 6 in the middle, as he says. And I'm back again with George. And George, tonight's a special night.
Yeah, tonight is our anniversary night.
Our 1-year anniversary. That actually, things have been so busy, somebody had to point that out to me.
Happy birthday!
If we rewind back to the beginning of the podcast, I remember distinctly having a conversation when we were thinking about doing this and trying to figure out if we could muster up enough topics to go over 5 or 6 episodes.
Yep. I remember the very night of that conversation when we got to number 5, like we were really excited we made it that far.
Yeah, and that assumes about an hour per episode, so I think we've overachieved on that.
Technically, we really should be celebrating our 2nd year anniversary because we've given folks 2 years worth of content.
Well, no, our podcast is weekly. You just get it in biweekly doses.
All right. Well, Mark, how are you doing this evening?
I am fantastic. How are you guys?
Good. It's good to be back.
Doing really good.
So
I am great. I am pleased to be back. Thank you very much for having me back on.
Well, if you keep coming, we're going to keep asking, and we appreciate you being on. Now, tonight, first of all, I have an update that I think will be of interest to our listeners.
What's that?
Our first update is on all of our project boards. So, of course, opposite weeks of our show is the flagship Ham Radio 360 podcast hosted by Cale Nelson, K4CDN, our illustrious founder and friend. And Cale pointed out some information about the antenna analyzer board. Is when we came back from Dayton, we had a few left. Those went with Cale. Cale has put them in the Ham Radio 360 shop, which if you go to hamradio360.com, click on shop, there is a link in there for project boards. And as of last week, there were less than 100 left. Now, there are a couple things that are a little bit different about this run. First and foremost, when these are gone, that's it. The antenna analyzer Rev 1 will no longer be manufactured or sold by us because we are behind the scenes diligently working on trying to come up with a viable and not ridiculously expensive or complex version 2, which moves away from the germanium diode. So rather than doing another run of these boards, we want to really focus our effort and attention into that. And, Barrick being gracious enough to help us with that, that's where we want to go. So if you want one of the antenna analyzer boards that we have made and sold, again, hamradio360.com, click on shop, go to the project boards. Less than 100 left as of last week, probably fewer now. And once they're gone, they're gone. Now, there are 2 other things that have changed versus previous runs of the board. Number 1, Cale is only going to be mailing these out once a week. Previously, every time he got an order in, he would drive, and get it out. And God love him for doing it, but we implored him when we realized every time he goes to the post office, it's like 20 minutes each direction. So to kind of make things a little bit easier, Cale is going to be sending those out in batches once per week. So don't worry, you will get your board. It's not going to necessarily go out the next day, but they will get shipped out the same week. And then finally, Cale is no longer offering international shipping options because of some squirreliness with the post office. So that is the antenna analyzer board.
Hey, one more comment on that.
Yes.
So if you're thinking about getting the antenna analyzer and you're thinking, oh, okay, well, I'm going to just wait for the second generation of the board, we're not really sure when that's going to be available. So the design is not done yet, and it certainly hasn't been tested. So it's going to be a little while.
I'll go a step further, and I can tell you it definitely will not be any time in the next 3 months.
Yeah, for sure. Not for the next 3 months. Hopefully before the end of the year, I would say.
Yes. So that's update number 1. George, I believe you had an update on the firmware for the beta power board that 50 of our lucky listeners were able to pick up from us at Hamvention.
Yes, those boards got snapped up really quick, and those are the ones that have the power gate function and the low voltage disconnect and the voltage and current metering, and they all went really fast. I think they were all gone the first day, frankly. And Ed, W6ELA, is the guy who has written the Rev 1.0 firmware for that board. So that firmware version is available now. It's posted on the 360workbench.com webpage. So if you want to go ahead and download the source code for the power monitor boards, go right ahead. And we are going to make a few tweaks to that board. If you recall, that's the one where I picked the wrong transistors. And fortunately, we were able to find a different set of transistors that were the same footprint. We could swap out and the board would be fine. The next generation of that board, the next batch, will have yet a different transistor because we found one that's even better. So the first one had a 75 ohm on resistance, 75 milliohm on resistance, which was way too high. The replacement transistors were about 4.8 milliohms, and that's fine. But the even better ones are about 1.7 milliohms on resistance, so even better. But they're in a different package. Since it's a different package, we had to relay out the board for those components, and we have to work through that still. So there will be more power monitor, power management boards coming eventually also, probably sooner than the new antenna analyzer, but we don't have a date yet for that, probably a couple of months.
And in addition to that, of course, we had at Dayton our dummy load and what I call our Smarty load, which is a dummy load with an Arduino on it. Those boards are currently on hold. We have several of them left, but we're currently taking a look at how best to improve our logistics in order, as far as serving our listeners and getting boards out to people. And so those will not be offered for sale until we have probably at least one other project available again and have figured out a new way of handling logistics for that. So with that housekeeping out of the way, it's my favorite part of the show.
Yeah.
Oh, wait a minute. No. George, you had news.
We have a factoid. It's not a big, long item, but I did find out this morning, posted from one of the main guys at Dayton Hamvention, that they posted the attendance for Hamvention this year. And I don't recall the exact number, but it was about 29,000 plus attendees. And last year, I think it was about 24,000. So they were up a solid 5,000. And I think that's remarkable. I really couldn't tell at the show if it was more or the same. It felt just really crowded, not unpleasantly crowded, but like really, like very popular. But up 5,000 to 29-something K attendees. So that's awesome. Congratulations to those guys.
I'll make a comment about that. Mark, I know you've never been to Dayton, but one of the things that in Hera that you would often have to contend with in some buildings is that the rows between, or the aisles between booths could get pretty narrow where there might only be enough room for two people to pass shoulder to shoulder. And you would be in a hurry trying to get somewhere, but invariably there's somebody stopped in front of you looking at something or waiting to talk to somebody, and you just have to wait for the traffic to pass. I've had many fewer instances of that at Xenia.
Nice. So next year, if everybody goes back, it'll be 29,001 because I'm doing my best to get out there next year. I listened to your last episode about Maker Faire, and I was at Maker Faire this year. And I think Kenneth hit the nail on the head that the way to do it is to kind of oscillate back and forth, because I went to Maker Faire for several years kind of early on, and then I took a break and I went back again this year for the first time in I think 3 years. and it was amazing again. It was awesome. There was a lot of new stuff, and it had that new energy again, and I was very excited about that. But I haven't done the Hamvention thing yet, so I'm hoping that I'm going to be able to make a drive out there next year to get out to Hamvention.
Outstanding.
That'd be awesome.
Yeah, we'll put you to work.
Hey, also Kenneth had another comment when he was talking about that alternating event idea, which is that a lot of the fun winds up being having the time to hang around with friends who you may never see except at that event. And the same is totally true for Hamvention. I mean, it's obviously true for Jeremy and Cale and I, because we are in different states. We never see each other during the year. We only see each other at Dayton. But our other friends and listeners who are kind of in the same crowd now show up there. So it's really a lot of fun. And it's not only fun for the show itself, but it's really great to see the listeners and friends, and not that listeners aren't friends, but it's that whole hang out with your ham buddies.
We do have some friends that aren't listeners, so
and we do have some listeners that aren't friends, but we're not going to go there.
Yeah, I've got that. I have the same thing with DEF CON every year. I've been going to DEF CON for about mumble years now, and there are a lot of people that I know from DEF CON that are my once a year friends, right? Twitter has kind of made it easier to keep in contact with them throughout the year, but yeah, every year at DEF CON, I look forward to meeting up with the people much more than I look forward to going to DEF CON. So I'm right there with you.
So yeah, it's exciting to see that the attendance was up. I know that they're hard at work already starting to figure out where there are opportunities to solve problems. It's just you're gonna be there the year they perfectly stick the landing, I feel like. So that's awesome.
Yeah,
we look forward.
I'm looking forward to it.
They did mention in the email they sent out today with the attendance numbers that there's going to be some significant new features of the venue, and they didn't go into detail, but they did mention that the things where they had some challenges with the mud and all that stuff out in the flea market, that they get that, and they're going to work to try to figure out how to make that better. I don't know how you do that, but hopefully they will.
By paving it.
Like lots of straw.
Something, but they made some vague allusion to a bunch of really cool new features of that facility. So I think having Hamvention there helps the county figure out how to pay for upgrades to the facility. So it's one of these things where if you go to it, more people show up, and there's more money to actually make it better. So when you go back, it's better than it was before. So it's very much a positive on a positive roll there. So. Just will be getting better, I think.
Yeah, I'm looking forward to it.
So let's start with our guest, Mark. What is on your workbench this week?
What is on my workbench this week? Well, let's see here. The main topic for today, we're going to be talking about the BITX40 in a little bit. I've got that on my workbench right now because I figured if I am going to talk about the BITX40 and explain how it works, I better have one that I can actually use and turn on. So I got that up and running. Packed it into a case. The one that I'm using right now is the old school one with the analog VFO, not the newer one that has the Arduino and the SI5351. We'll go into what that means in a little bit. But so I've got the old analog VFO one in a box that I can get on the air right now. I have another one, the one with the Arduino with the digital controls on it, that I will be building as well, along with our listeners as we go through that. We'll get into more detail on that in a little bit. The other big thing that I have on my workbench right now is unfortunately not the kit or the device I was working on earlier. People who follow me on Twitter have seen me posting videos about SOAR, the satellite optimized amateur radio. I've kind of put that one on hold for just a little bit. I've got some other things that are time sensitive that I need to get done. But I will be getting back to the satellite optimized amateur radio. And I hope to come back onto another episode and describe what the heck that is. But this week, what I am doing is I am a member of our local Renaissance Fair Guild. And our local Renaissance Fair is coming up in a few weeks. And we are in California, where you are not allowed to have fire anywhere. So we can't have lamps, we can't have lanterns, we can't have fires and pits and whatnot. And it gets very dark after hours in the pavilions and around the Renaissance Fair. So what I'm doing is I have found a bunch of old lanterns, kind of wooden lanterns with smoked glass and whatnot, and I'm putting bright LEDs, warm white LEDs in these things, and controlling them with a microcontroller so that they flicker like a candle or like a flame, and bundling it up with a battery or rechargeable battery, so that once it starts getting dark outside, we can turn on these flicker flames and have period-looking lighting up our whole pavilion, and kind of turning our pavilion into kind of a central social hub for people to come to because it's well lit. Whereas all of the other ones have the really harsh lighting of, like Coleman camp stoves. It's after hours. You don't have to be period anymore, but we kind of like to stay period because it's fun. So that's what I'm working on.
So I got to ask you a question. So yeah. Are you writing firmware for a microcontroller to do the flicker algorithm?
Yes, I am.
What's really hilarious is I had this exact conversation with my wife yesterday. So she's a middle school science and engineering teacher, and we're talking about projects that the kids could build in her class. And okay. and she said, she's doing some hands-on projects with LEDs, making little lanterns and stuff like that to teach basic electronics. And I said, man, we should connect a microcontroller so we can make the thing flicker like a candle. And anyway, so what you're describing was like, that's the thing. So
that's exactly it. I'll send you a copy of the boards.
That'd be great. I'd love to see it.
It's an AT-Tiny 85. It's actually a DigiSpark. So it's a little tiny microcontroller. They have 2 PWM outputs. I've run those into a pair of IRF 510 FETs to be able to source the amount of current that these LEDs, these super bright LEDs need. And yeah, I've already written the code that does the flicker.
Oh, that's awesome. Yes, send me a board.
Okay, will do.
We get build project number 25 queued up here, Jeremy.
Yeah, that's right. A microcontroller to simulate a candle.
Yep, exactly.
There's something so awesome about that. It's like going full circle.
It really,
we're using technology to simulate non-technology.
Yeah.
And the funny thing is, someone's going to come by and say, you know what? That flickering candle looks more like a candle than any candle I've ever seen before.
Yeah. Well, I'll be perfectly honest with you. I'm kind of hoping it gets to the point where the other guilds come to us and say, that is really cool. Can I have one? And then we get to start selling them and make them as a kind of a fundraiser for the guild.
So are you the ye old Arduino guild?
We are Hounds Haven. We are a tavern.
Awesome.
But yeah.
All right.
So which Ren Fair is this? This is not the LA Ren Fair, is it?
No, we have one local in San Luis Obispo.
Ah.
Yeah. No, it's neither Southern nor Northern Ren Fair.
It's Central.
Yeah, Central. Yeah. My guild goes to various different other Ren fairs, but this is our hometown fair.
Well, that's awesome. I'm looking forward to seeing that.
Yeah, it'll be fun.
So, Jeremy, what's on your workbench?
Well, not strictly related to my workbench, but something that was worth noting that a coworker of mine pinged me about yesterday. So, as you guys know, I like 3D printing. There is another podcast that I listen to that I think I mentioned before called 3D Printing Today. And every episode, whether I think I'm going to be interested or not, I learn something. But my coworker pinged me and said, hey, I heard you on the 3D Printing Today podcast, because earlier this year when I went to Midwest Rep Rap Fest back in March, I interviewed the guys at E3D who make, hot ends and extruders, and talked to them about a new product they'd launched. But anyway, I sent them the interview audio, said, if you want to use it, cool. If not, no big deal. And so they put it in the episode. And so that was cool. That's this week's episode. I think it was 191 or 192. So that was neat. Otherwise, I haven't actually been really building anything. I mean, the printer is still in process. Still, my new 3D printer is still in process, still 50% done. I've been very busy this week, but the week before, I've really spent a lot of time playing with my AirSpy software-defined radio receiver.
Oh, neat. What are you doing with that?
Honestly, okay, one of the things I meant to pick up at Dayton and forgot is Diamond makes a miniature disc cone antenna that's called the D220R. It's rated for 100 megahertz to 1.6 gigahertz. It's a cool little compact disc cone. And I wanted it basically as just kind of a general receive, but also potential transmit antenna for, the common, VHF, UHF, et cetera bands. So I picked that up. Basically, I just plugged the dongle into my laptop. It's a Windows laptop, incredibly low powered, like 4 or 5 year old, dual core Atom. This was a Best Buy Black Friday buy a Lenovo laptop for $189 cheap laptop. Okay. Mm-hmm. So, the software that I run on Windows is called SDR Sharp, which is the software written by the folks who design and manufacture the AirSpy and the AirSpy products. And so basically, I just plugged it in. I started just trying to play around with all the sliders and get really familiar with what happens when you change settings and whatnot. But then I started taking a manual kind of survey of what was going on in the RF spectrum around me. And then I learned a few things because we have so many ridiculously strong AM and FM stations in the area. I actually bought AM and FM broadcast band blocking filters. So that actually helped, quite a bit as far as the sensitivity and seeing signals, even though this antenna isn't rated for it. I've actually at nighttime here lately been getting a lot of digital modes on 10 meters, like being received on this Discone antenna that's rated for 100 megahertz.
At night, you're receiving digital modes on 10 meters at night?
Yeah.
Yes. And when I say night, I'm talking about 8, 9 o'clock at night. Yeah. Some
that
Olivia,
is impressive.
Some JT65, a little bit of CW. Yep.
Now, which software are you using on that?
So that's, again, SDR Sharp, which we'll make sure to put a link to in the show notes. SDR Sharp is free, and what's cool is if you're a Windows user, they also support the inexpensive RTL SDR dongles. But the AirSpy, I have an AirSpy Mini. You get a lot more capability. It's a more sensitive receiver, better dynamic range. There's no DC spike in the middle of the receiver, and it gives you up to 6 megahertz of bandwidth instead of the 2.8 I think you get out of the RTL SDR. So basically, I can see the entire 2 meter band. But
that's great.
Yeah,
I'm surprised you're getting your hearing stations on 10 meters. I would think it'd be kind of dead ski. Did you hear any CW or other stations or just digital stuff?
There was a little bit of very, very weak CW that I was hearing. And of course, people, so this is something else also funny. As I was in my room, I didn't have a radio up there. I had this thing set up. I set it to the 2 meter band and I was tuning into a couple nets. And the reason I started even looking at 10 meters is because on one of the nets over the weekend, somebody was like 10 meters has been open towards the end of the day like crazy lately. So I don't know. I mean, I have no idea where these stations are coming from. I didn't bother trying to decode it, but it was still really awesome. I've also, again, just doing a survey of what's around and have run into a ton of just interesting little data beacon signals spread all over the place.
It's kind of neat what you hear when you go looking for it.
Yep.
There's a lot of stuff out there.
Yes, there is.
Well, I'm not surprised you hear some beacons because the beacon networks, the DX beacon networks, a lot of them are on 10 meters because there's plenty of spectrum there. And, when it's in, right?
Those aren't the beacons I'm talking about. I mean...
Oh, what are you talking about?
So, for instance, somewhere around here, around 150 something, I can't remember the frequency, but... there are these little short bursts of data that go like, bzz, bzz,
oh, so you're hearing non-ham stuff. You're hearing other stuff.
Bzz. Yeah, and I think those specifically might be our local power meters. But I mean, just there's a lot of interesting, like I said, little data bursts, little data beacons, all over the place. The ham band that it coexists with the 900 megahertz ISM band. I am just shocked at how much activity there is up here, considering where, just based on where I live. So
but presumably that's ISM activity, not ham activity.
Yes, presumably.
Yeah.
Although actually, I don't know, because there were a couple of very wide signals up there. But there were also some spread spectrum things going on up there because you could see a signal, bouncing around in the waterfall. In seemingly random patterns. And but I mean, it's just cool. It's another way of knowing what's going on around you. Again, I want to give a shout out to our friends at airspy.us who graciously hosted us in their booth. And airspy.us is where I have purchased my AirSpy Mini, as well as several other accessories. Actually, that reminds me, I need to shoot an email to Barrick because I want his Python script to use the noise generator and the directional coupler as poor man's test equipment.
And while you're at it, tell him to get with it on the new version of the antenna analyzer.
Exactly.
Oh, come on. Because the guy's got nothing else going on.
Well, actually, he's going to be very busy over field day because he's one of our field day coordinators. He and John, too, from shouldn't call him John, too, but John at Dayton are our field day captains this year.
Oh, wow.
Nice.
So, yeah.
So, George, what's on your workbench?
Oh, I had one more thing.
Oh, you did. I'm sorry.
Yeah, so this will be very, very short. But so, of course, this weekend coming up as we're recording this is Father's Day. And I got a cool project that my daughter and I are going to be working on. So as much as I would love to go out and buy every Lego set made because I'm still 5 years old, I restrained myself. But recently, actually on June 1st of this month, okay, on June 1st, Lego opened pre-orders for their brand new Saturn V Apollo set. So,
which is awesome.
This if you have not seen this thing, which I'll put a link again in the show notes, this rocket when put together is over a meter tall. All of the stages come apart just as they did in real life. There's actually a little LEM and a command module and a service module, pretty much everything but the flag and the lunar rover.
Oh, nice.
Yeah, and it even comes with a little stand you can build so you can take it all apart and display it really nice. Another thing that's interesting is the kit consists of 1,969 pieces, which of course
it does.
Which is significant. The whole thing for as big of a kit as it is and as nice as the model is, it sells for I think $120, which I think is very reasonable for a Lego set of its size.
I honestly expected it to be $250.
Yeah, so did I. Because just like the Ghostbusters Firehouse was $300, and I think it only. It's an amazing set from the Lego Ideas stuff. So I'll put some links to that. And I very much look forward to building that with my daughter because this will be her first experience with real Legos.
Nice.
I'm looking at a picture of it on the web. That's an awesome model.
Hurry and order.
And the funny thing is, for those of you who are thinking about what a Saturn V would look like made out of Lego, you're going to think it's a rectangular object, but it's not. It's cylindrical. It's really nice. Very nice.
Yeah.
Did you order?
I've been drooling over that thing since it was. No, I haven't ordered one yet, but I need to. I should point out to my wife when she wakes up that Father's Day is this weekend. I should talk to her about that.
And that we're all 5 years old, but she already knows
That's
that.
right. And she already knows that.
Mark, you have the excuse you could build it with your daughter.
That is true. My daughter is a space nerd fan and also likes Lego. So when she was probably about 4 or 5, when people would ask her what she wanted to be when she grew up, she said she wanted to be a ballerina in space.
Nice.
I love my daughter. She's awesome.
Well, my youngest is in college, so it doesn't matter because I'm still 5 years old too, so that looks pretty cool.
Well,
and if he doesn't want it, that's okay.
Well, I really wanted to buy 2. I wanted to buy one to collect and one to build. One of my biggest regrets ever is that I didn't buy one of the Mars Curiosity rover sets.
Oh, wow.
Me too. Yeah.
Yeah, because, I mean, they now sell for like $200 to $300 on eBay unopened.
Yeah.
So, George, now, what's on your workbench?
Well, glad you asked. I have an unbuilt BITX40. So I had to get it before the show here. So I finally cracked open the cardboard box, and inside is a plastic box with the hardware. I'll leave it at that. So I'm excited to learn more about it from you, Mark. So that'll be cool. So that's one. I still have my Whisper transmitter project that's unbuilt because of all the run-up activity before Dayton. The only thing I've really
Ultimate 3?
Yes.
Yeah. Great. Cool.
Yeah. I'm really excited about that. Also, I was hoping to have that thing done before field day because I wanted to fire it up on field day and see what the propagation looks like on the WhisperNet reporting sites. So that may be a project for next year. It's not really workbenchy, but getting all the gear ready for field day, making sure all the batteries are charged, making sure all the connectors are there and the cables are there and all that stuff. And the last thing, probably the most hardware designy thing I've been working on is a few episodes back, Jeremy, we talked about the repeater site monitoring project. And one of the things I'm trying to figure out is how best to measure plus and minus differential voltages. All of the voltages that we want to measure to start with at the repeater site are all 5 to 15 volts or so, and they're all referenced to chassis ground. And so the way we built the controller was really simple. We just have a voltage divider going into the ADCs, and it works fine. But what I've come to realize is there's some applications where you want to read a voltage that doesn't reference to your chassis. And in some cases, there's negative voltages too. So that means that I have to come up with a much more complicated circuit to measure the voltage. So I'll share that eventually when I get sorted out. I think I've got the design figured out, but I have yet to build it and try it out yet. So hopefully I won't destroy any components in the process, but that'll be coming. So that's pretty much what's on the bench at this point.
That resistor had it coming anyway.
Yeah, it was the integrated circuit that wound up in two halves across the room. That was the nasty part.
Yeah, the rather exciting failure modes.
the single use fuse integrated circuit.
That's right.
Speaking of field day, so we talked a little bit about that with Barrick last episode. So this week was the Ohio Valley Experimenters Club meeting, and it was all about prepping for field day. And we are going in a radically different direction this year, when I'm really excited about it.
Different from what you talked about on the last show?
A little bit, yeah. So the club has decided we're going to run 3 Alpha Bravo 100% QRP.
Oh, awesome.
So what's ridiculous about this is that our vice president, Ben, has a 5-element tri-band Mosley.
Oh, and nice.
Our president and our secretary have been busy over the last week and a half welding a collapsible tower onto a trailer.
Okay.
So they now have, I don't remember if it was 30 feet total or 60 feet total on a trailer that they're going to wheel up to our site, and we're going to put this ridiculous beam on top of it, and it should be pretty awesome.
So I'm not familiar with the Alpha Bravo mode. Is that QRP specifically, or I know Alpha means that you're running on generator power or emergency power? I can't remember what Bravo meant.
No, Alpha means you're 2 or more people in a club station.
No, because you can do 1 Alpha.
Yep.
Oh, 2 or more people. Sorry. Yeah.
Yeah.
Okay.
So, and the B means battery, doesn't it?
Yes.
The B means you're on battery.
Yes. The reason we're doing QRP, because I have done full QRO field days before, 100% on solar and battery. And you actually don't get any points for that. You get like some solar alternative energy contact points. But the reason we're doing this is because the base multiplier for QRP field day sites is much higher. And our secretary did some modeling based on the average number of contacts we've gotten over the lifetime of the club. And we would actually have higher points by going QRP, even assuming we only get like 35% the number of contacts. So we're going to be running a CW station, a part-time CW, part-time digital station, and then 1 phone station, which I will be bringing my Elecraft KX3 for.
Very cool.
Your Elecraft KX4? Are you spilling the beans?
My Elecraft KX3 4. It's the KX34. No.
The KX34.
I will be utilizing my Elecraft KX3 as the 3rd QRP station at Field Day for voice.
So when you say QRP, the classic definition is 5 watts or less. Did you guys go with 5 watts or a little bit higher?
We're doing 5 watts. I mean, honestly, it's one of those things where because of Elecraft, I very much want QRP to be redefined as 10 watts. But unfortunately, I think just the years and years and years of history are against me, unless like the QRP ARCI guys or whoever is the QRP standards body decides that 10 watts is QRP, then I just don't think that's likely to happen.
Yeah, I don't think that the legal definition will ever change from 5 watts, but I'm not sure
know the difference.
for field day purposes. Do they define QRP as 5 watts?
I have to look, but I do think they do.
I think they do. I think the three groupings are 5 watts or less, 100 watts or less, or full legal.
Yeah, I think that's right.
Yeah.
Now, Mark, just real quickly, obviously you weren't able to join us for the Maker Faire episode, but what are you doing for Field Day?
So I am going to my daughter's dance recital.
Is she going to be on 20 phone or CW?
No,
one Bravo?
She will be on stage dancing hip hop and various other things. Yeah. So her dance studio always does their big dance recital the fourth weekend in June. So it pretty much always falls on the same weekend as Field Day, which means that I can't go away somewhere to go do Field Day. I will probably be doing some 1 Delta from the house. If W6BHZ is doing Field Day, her dance recital is actually on campus at Cal Poly. So I might be able to break away for some time and head over to BHZ and work a little bit there. Although they'll probably be using N6CP because it's a shorter call sign. The club has both call signs for reasons I won't bore you with here. But I do look forward to one of the few years where they end up not falling on the same weekends. There is a mountaintop near here called High Mountain. It used to be a fire lookout point. It's at 3,100 feet. It is the highest point around in the county. And it used to be a fire lookout point. So there's a building up there with a kind of an outdoor toilet and various other facilities. There's no water. But there is this building that's kind of well maintained. The fire lookout, I guess Cal Fire has gifted it over to the Condor research groups, and so it is a building that is used regularly for looking for condors in the area, tracking condor movements. But they don't go up there all the time, and so in the past we've been able to coordinate with them and say we're going to go up there and put up a bunch of dipoles and verticals and whatever else. And it won't get in the way of the condor tracking people because they won't be up there that weekend. And it is a phenomenal site. 3,100 feet. It is by far the highest thing around. There is no electrical noise up there. It is absolutely glorious. I look forward to being able to get back to that one of these years.
Yeah, that actually sounds really fun. I'd like to be able to do something like that sometime. But there's not really much elevation here. In fact, I live in, because I'm at the top of the ridge of a valley, I live in one of the higher areas around. But speaking,
I live in a valley. I live in a hole.
Awesome.
Yeah.
Well, speaking of QRP Field Day, that's a really good segue into what we're going to be talking about tonight. George, what are we going to be talking about tonight?
Tonight is all about a new build project. And this time it's all about building a radio. So let's dive into that right after this message. Elecraft is one of my top picks for high-performance HF radios. They make fantastic base station style radios, amplifiers, pan adapters, and other station accessories. They're also the designers of the KX3 and KX2, the ultimate portable HF radios. If you're thinking about SOTA, portable operating, or travel, you really need to be looking at Elecraft. Elecraft has some of the best designs in the industry, compact, high-performance, feature-rich designs. You're really going to love them. And Cale just got his KX2. So be checking out the Ham Radio 360 podcast and also the Facebook page and see what he's doing with his KX2 radio. The KX2 is my personal favorite for going portable. It's ultra small, 80 through 10 meters, sideband CW and data modes, and the thing runs 10 watts on the internal batteries. You'll love it. Check it out at elecraft.com. So on tonight's episode, what we wanted to talk about is a new build project we had in mind, and several of our listeners asked if we would do a radio build project. And so Jeremy and I were talking about it, and we thought, well, neither one of us have ever built a radio from scratch, so maybe that's not going to happen. But there must be a good radio kit out there that might be a good starting point. And so we looked around at some of the possible radios, and the one that we settled in on is the BITX40 transceiver. And it turns out that Mark had decided to build one of those things. And so we thought, well, this would be a great opportunity to talk about the BITX radio, where it comes from, what it is, why it makes for a good kit, build project, and explore how the radio works. So that was the idea behind it. So the BITX40 is made by a company called HF SIGS, www.hfsigs.com. And the designer is Asher Farhan. And he's become a fairly famous guy now, because if you listen to the Solder Smoke podcast, Bill talks about Asher many times and has talked about the BITX, and they've built them, and thousands and thousands of hams have built these radios. So we thought that rather than us trying to come up with something, that we should go with something that's well known and well documented. So the idea here is that we pick the radio kit, we announce it here on the show, and we'll talk about it tonight in some detail. And you, the listeners, what we want you to do, if you want to follow along with a hands-on experience, go to hfsigs.com and buy yourself a BITX. And over the next couple of months, we're going to do segments on the show here talking about the BITX40. So tonight, we'll kick it off with Mark talking about the design and how the radio works and what attracted him to the radio and what he's going to do with it. And then over the next few months, we'll have some other sections of the show, some segments talking about different aspects of the radio. We hope to get Farhan on the show itself and do an interview. We talked at Dayton, and he said he'd be happy to participate, so we need to set that up. And if you listeners go out and put these radios together, we can compare notes and see how you built the radio, how you packaged it, how you use it. Did you modify it? Did you hack that radio? And we could learn from one another. So that's the big idea. So all that should take place over the next couple of months. So warm up the credit card and go ahead and buy yourself the radio kit. So to get into
the good news is it doesn't have to be too warm. It's only $59.
Yeah. Oh, you took the big punchline.
Oh, sorry.
Yeah.
Sorry.
There you go. Big punchline. Yeah. So it's only $59.95. I mean, what could be better than that? When I ordered mine, I think it showed up in like a couple of weeks. So they get here pretty quick. So with that, Mark, why don't you walk us through a little bit about the BITX40? What are some of the highlights of the features of that radio?
Absolutely. So the BITX40 is a 40-meter QRP single sideband kit. And I'm going to explain what all of those terms mean if it may not fully sink in exactly what that is. So 40 meters is the band, obviously, right? The 7 megahertz band between 7.0 and 7.3 megahertz. I think the radio is designed to tune any 300 or 400 kilohertz section right around there. So it'll tune the entire 40 meter band. QRP, as we were just talking earlier, QRP means that it's low power. Technically, it's not low power because you can get technically it's not QRP because you can get about 7 watts out of it. But 7 watts under kind of ideal circumstances, right? Most of the time, you're only going to be getting about 5 watts out of the thing. So it definitely qualifies as a QRP radio. Single sideband. All right. So we all know what single sideband is, right? That's operating voice on HF as opposed to Morse code. The reason this is significant is if you look at most of the other QRP kit radios in this rough ballpark, these sub $100 price range, most of them are Morse code. Because the reason for this is a Morse code transmitter is much easier to build than a single sideband transmitter, or at least conceptually. Farhan actually does some very ingenious things that make it very, very feasible to do a single sideband transmitter with relatively few parts. But a lot of the QRP kits out there, a lot of the radios that I was looking at when I was looking for kits to build to kind of get me into building radios, most of them were Morse code. And I am not a hater on CW. I love CW. I want to learn CW, but I haven't learned CW yet. And that was kind of kind of a roadblock. And I built a QRP Pixie and I built a 49er, and I'm like, great, now what? And I kind of, I was looking for something that would do voice, that would make it a little bit easier. And the BITX40 fills that need. And then it's a kit is the last bit of that description. And a kit meaning you've got some assembly that you need to do. Now, it is not a kit in the sense of like the QRP Pixies or the 49ers, which are these little, 10 centimeter by 10 centimeter kits you can buy on eBay for, between $3 and $20, depending on which kit you get, where you have a blank board and you have to put all the components on it and solder it together and solder all your connectors on and all that fun stuff. The BITX40 comes as an assembled and tested board. The entire board assembly is completed, which is probably a good thing for most novice kit builders because it's all surface mount, almost exclusively surface mount. But the board is assembled. So what's kit about it is that you have to put it in case. You have to hook up a battery connector to it or a power connector. You have to hook up the volume knob and the tuning knob and the headphones or a speaker connector and a microphone connector and the push to talk, right? So you still have some assembly, and that kind of assembly lets you play with the form factor. Is this going to be in a big box that sits on my desk, or am I going to be able to put this in a small, lightweight case with a built-in battery that I can throw in my backpack and go hike to the top of a hill with, right? Those kinds of decisions are still up to you as the kit builder, but the radio part of it is pre-assembled and pre-tested. So if you're just getting started with a kit, you have a very high likelihood of success, because a lot of the quote-unquote hard parts, or I'll call them the intimidating parts because they're really not that hard, but they can be intimidating. A lot of the intimidating parts are done for you. And so it is a really good starter kit for that reasons. 40 meters is a great band. It's open the vast majority of the time. QRP, it's low power, so your mistakes are not going to be all that spectacular, right? If you're running on a 100-watt rig and you make a mistake, you're going to know. You'll feel it, right? With QRP, things get warm. It's not that big of a deal. Single sideband, if you're not into CW, you can still use this kit and do it on voice. And it's only $59 shipped. So if you do make mistakes and if you do destroy the thing or break it in a way that can't be easily repaired, you're only out $60. You can buy another one, or it's not that huge of an investment to get into it. So in my mind, it's kind of the perfect get started in kit building kind of kit.
So let me throw a couple of comments on there. So I think one thing to point out is that this is a super useful kit. Even if you're not a licensed amateur radio operator, if you're listening to this show and you're going to be a ham, you're interested in it, but you don't have your license yet, even though this is a transceiver, you could build it and just use it as a receiver. So for $60, it's a great starter receiver. The other thing I would be curious to know what you think is 7 watts is not a lot of power. And the reason why CW QRP works is because you have a better signal to noise, essentially, about 10 dB better with CW versus sideband. So could you give us some of your thinking on, is 7 watts really practical for single sideband?
If the bands are open, yes. So it's, I've got my 100-watt rig in the house, and or in my car, and when the bands are in great condition and you're talking to people, then you're 5/9, right? Or 10/9 or whatever. You've got a big booming signal even with only 100 watts if the bands are in the good shape. Dropping that 100 watts down to, call it 10 watts, it's 10 dB down. What is that? 2 S units, 2.5 S units, call it. Right around there. And so you definitely will have a weaker signal, but a lot of people run with more power than they need to be running anyway. If we actually paid attention to the rule that says don't use more power than you need to, if we were to actually turn the power output knobs on our radios down when we had big, strong booming signals, I bet you a lot of the times we would be operating down at QRP. Now, having said that, you are going to need to be in a good band condition situation for those kinds of things to happen. But I have heard stories about people getting their DXCC, the DX Century Club, where you've operated 100 different DX entities, all doing QRP, right? It can be done. You need good antennas, you need good feed line, and you need good band conditions, but it can be done.
So I think that the tip there, you mentioned a good antenna. So I think here's a case where a full-size antenna will make a difference. So if you could put up, let's say, a 40-meter half-wave dipole, that will be way, way, way better than like a ham stick on 40 meters. So 7 watts single sideband with a 3-foot whip is just not going to be a fun day at the park. So be thinking about building or getting yourself a wire antenna that's full size, like a dipole, or make an inverted V. Get a painter's pole and some wire and some coax and make yourself an inverted V. It's really simple and easy to do. So that would give you a pretty good chance of having reasonable results.
If only we had some friends of the show who made and sold antennas.
If only
that people could use. If only.
Do you realize you realize I said go out and make yourself an antenna? I didn't say you should go buy one.
Fair point.
But now that you've brought that up, so that you make some really good points. I think as your first kit, the last thing you want to do is build something that is incredibly complicated, because there's a good chance that something's going to go wrong, and you don't want to sit there with after 20 hours of work with this brick, right? So you really want something that you could put a couple hours of effort into and actually have the thing work.
Yeah. Oh man, there is nothing better than that feeling of success. Even if it's it's a quote unquote simple success, just having that success is so much better than, this is going to be a great kit when I get it done. And you spend weeks trying to debug the dang thing. So it's get that success under your belt. Especially if you're just getting started, the knowledge that you can do it, like the real honest to goodness, firsthand knowledge. I have done this, not just, I should be able to do this. Man, that is, don't underestimate it. It's huge.
So with that as kind of a little bit of background, you explained why you picked the radio from, ease of construction and it's inexpensive and all that. So once this thing is done, what are you going to do with it?
What am I going to do with it? Well, I'll be honest with you. A large part of it was just the build, right? A lot of my hobby is the build itself. Having said that, I have built an awful lot of things for ham radio that I have never used, or I used once and said, yep, it works, and I put it away. The BITX40 is actually one I'm looking forward to being able to use. Where I live in a small valley with hills all around me, and the noise floor at my house is absolutely ridiculous. It is on 40 meters, the noise floor is routinely S8 or S9. Just constant noise. It's not like a buzzing from electrical like switching or anything. It's just background white noise. It's insane. So I really need to get away from the house to be able to operate in the clear and get some good stuff. And so I'm kind of actually thinking I'm going to use the BITX40 as a not mobile while driving, but go somewhere, set up, and use it kind of rig. I'm looking forward to packaging it up for something like that.
So, Jeremy, have you looked at these radios before?
You were the first person that had mentioned them to me. And once you did, I noticed that they were getting really hot, and I noticed that there were a lot of people who were building them. I started seeing a lot of videos of people online, folks starting to modify them. So, I mean, at first it was a little hard for me to wrap my head around, because I was like, it's a radio that somebody else has built and you're just soldering connectors and whatnot. But as I've learned more about it, I've learned how the board is actually structured and whatnot. I mean, it's become interesting. Like I admit I am one of those people that are going to have to order one in preparation for future shows.
I thought you were going to go all hipster on us and say, everybody's doing it now, so I don't want to do it.
No.
So you mentioned something there that the board is kind of like the circuit. Mark, you want to describe that aspect of the design?
How the board is part of the circuit. I'm sorry.
No, the board. I mean, the physical board layout is almost like the block diagram of the schematic.
Oh yeah. So actually, So I'll take this opportunity to plug a video I just did. Actually, I did it in preparation for recording this podcast. Go search YouTube for Smitty Halibut. I suspect we'll have a link in the show notes on this episode as well.
Yes, we will.
But I just released an episode earlier this week on the BITX40, specifically going through in great detail, kind of at a block diagram level, exactly how the BITX40 works with all of the frequencies and the mixers and the shifting and all that fun stuff. And I totally blanked on what your question just was.
So the physical layout of the board is similar to the actual block diagram, isn't it?
Yes. So the circuit board, Farhan did a fantastic job of laying it out in a way that you could look at and visually see how the circuit is laid out. And so you look on the board and there's like this obvious delineation of, here's a big block of components. And there's kind of a blank space, and then the next block of components, and then a blank space, and then the next block of components. Those blocks are the logical blocks in the block diagram, and you can point to an area on the board and say, oh, that is a bidirectional amplifier, because if you look at the block, it's kind of a large rectangular block. It is set aside from all of the other blocks, but even within that one, it's symmetric from one side to the other inside the block, and you'll note that it's two amplifiers, one pointing to the transmit side and one pointing to the receive side. You can visually look at the board and figure out exactly where the signal is going from point A to point B. It's really well laid out.
So from an like a educational point of view, as you're trying to learn what the functions of the sub-circuits are of the radio, it makes it easy to relate the functional block and the schematic to a grouping of components on the circuit board.
Yes,
and I think this radio is a really, really good vehicle for people to understand how a radio works, because it's not too complicated to be able to wrap your head around at least the basic flow of the circuitry, but it's also not trivial. So it's a pretty capable radio in a bite-sized package. The whole board is about 6 inches square, roughly.
I think it's even less than that. I think it's like 4.5 by 5. Yeah, it's pretty small.
So, George, what you just said is one of the things that makes me most excited about this, because, we have to study in the license manual and everything to, get the different levels of test. And we talk about all these components about like mixers and oscillators and all this, that, and the other. But I mean, this is truly like a visual guide to those components in action. And that I think is one of the coolest features of this design.
Yeah, exactly. It's funny because when we take our license exam today, I bet 90% of us cram for the exam. We go take the test. We memorize the answers. We pass the test. And then a year later, you have absolutely no idea what the VFO circuitry would look like, or what a filter looks like, because you just knew enough to memorize the answers to the questions. Most of us, anyway.
I took my technician back in the mid-'90s, and I explicitly remember on the test back then were things like, here's a transmitter and receiver and a TR switch and, a mixer and an LO and things like that. And I'm like, once I got my license, I started looking for those things in the hobby, and they didn't exist. I had an HT, right? I had a transceiver where all of those things were inside the HT. But as far as I was concerned, I had a radio with a push-to-talk and a speaker on it, right? And I didn't see the TR switch because it was internal. I didn't see a separate transmitter and a separate receiver. When I took the technician test, it was very obvious that the questions were left over from a bygone era when you had a separate box that was the transmitter and a separate box that was the receiver and a separate box that was the TR switch, right? And then when I started getting my advanced and my extra, they were doing a lot of the same things. Like, here's a mixer, here's an oscillator, here's a filter. And I kind of understood at a high level how those things worked, but I never saw them. Right, because they were all internal into my radio. And it wasn't until I started looking into kit building, honestly, the first radio design that I found all that stuff in and it started to click with me was a Minima. as another design by an Australian chap whose name I'm totally blanking on. But it was a very minimal QRP radio design. And he did another one called the Knobless Wonder, which was a very interesting one. It's all frequency controlled. And it wasn't until I started looking into those radios and trying to understand how the circuit was laid out that I started understanding like the internal structure of the radio and how things moved at a block diagram level. I'm not even talking circuit level. I'm not even talking about here's a transistor with the bias currents and the resistors all over here, and you got to bypass this with a capacitor. Not even at that level, right? No Ohm's law anywhere. I'm just talking at a block level.
Yes. Well, and that's super useful. And
it's very useful.
Getting your ham ticket is really like a license to learn. It's not these days. It's not that you're a radio genius and you've passed the test. It's pretty much you managed to pass the test, and now you can get on the road of learning about what you just tested out on. And a lot of times for myself, I'll think of some topic like I want to go build an antenna, or in this case, understand the radio. Go crack open the ARRL handbook and read up on that one thing, and then now years and years and years later, now all of a sudden it's meaningful to me. So this radio that you picked is a great vehicle for that, because you can look at that block diagram and go, oh, well, the signal path goes from the antenna jack through these 5 stages and pops out the speaker. And each of those stages maps to this bunch of parts. And to take it a step further, a lot of the episode content we've done in the early episodes of this show were about setting up your workbench and picking your oscilloscope and your hand tools and all that stuff. This radio is a great opportunity to do some probing around and look at some of those signals with your scope to get an even deeper understanding of what that signal really looks like. So, a simple example is if you ever listen to the audio coming out of an audio amplifier and it sounds clean, that's great. And then sometimes you'll listen and it sounds really raspy, really distorted. For me, when I can see what that signal looks like on the scope, that notion of the distortion, I could visualize it and understand that level of it so much better than just kind of the academic understanding or like hearing it. So when you can see it on the screen, you can see, oh, the thing is clipping at the top, or it's got some other signal imposed on it, some noise. So I think this will be a great project to actually crack out the scope. And, if you just look at the stages in the audio amplifier, what's the signal that comes out of the last mixer stage before it goes into the audio amp, and what's it look like after the audio amp, which it'd be interesting just to see that. Yeah. Anyway, kind of a big aside, but I think that this is a great vehicle for that kind of exploration and learning.
Call that aside, but I mean, like as I've described before, that's how I learn. If I can touch probes to something and actually see it, I mean, it becomes far more clear than understanding the math or just hearing somebody say blah, blah, blah. So I would assume that this radio would be safe to actually put, probes on. You're not going to blow your scope up with it?
Yeah. Well, there's nothing will be more than like a 12 volts, right? The 12 volt rail. So your probes should be safe to 12 volts, wouldn't they?
Yeah, that should be fine.
Yeah.
Yeah, should be no problem at all. You might not want to transmit into your scope. I'd be a little careful with that.
Well, of course.
But seriously, just make sure you don't have your mic plugged in when you're doing it. But the receiver chain, you can certainly kind of buzz through that. There's no reason why not. In fact, also, speaking of transmitting, the little QRP dummy load thing we did with the LED on it, or the Arduino version, that would be the perfect dummy load to go along with this radio, because it will easily handle the power. And you can actually use the Arduino version to measure the output power. As a thought. By the way, Mark, this thing does not do CW out of the box at all, does it? It's strictly single sideband, as I understand.
Correct, but that is a wonderful lead-in to one of the other points I wanted to make on this, which is that this radio, being laid out the way it is incredibly hackable. It is so easy to understand how the signal flows through this radio that if you look at the block diagram and say, all right, conceptually I understand what's going on over here, I want to make a change. I want to do this, whatever this is. And you know what stage you want that to be at. You can very easily point at the schematic and say, all right, it's right there on the schematic. And that very easily maps to the board because it's so easy to find. The reason I bring this up now is that there have been many people who have made CW modifications to the BITX40. I'll be honest with you, I have not looked at the circuit to figure out what they're actually doing. But in theory, there are simple mods out there that you can hook up a keyer to it and use it for CW as well.
Well, by the way, off the top of my head, there's two ways I could think of you could do it. One is you could do audio keying. So in other words, you can have the audio tone oscillator of your keyer, your external keyer, just pump that into the mic input, and you're essentially sending what's traditionally called MCW, microphone CW, or modulated CW, I guess, which might sound a little hacky on the other side, but it would work. The other thing would be you could probably pull the VFO, so there's probably a way to a point to tap into the local oscillator, and maybe you have a little transistor switching a tiny capacitor in there. So when the capacitor is switched into the circuit, it would pull the VFO frequency a little bit. So that might sound a little weird, but anyway, I'm sure there's more elegant ways of doing it. But there's got to be some way off those two off the top of my head anyway.
Yeah, the audio one was one I was thinking of, but it's the mod that I saw. I didn't dive into it, but it only had a few components that they were adding, so I think it was something similar or simpler than that.
So on the current version that's shipping, there are two boards. There's the radio board itself, and then there's a display board that has, guess what, an Arduino on the back of it. It is a Radduino. So could you describe what that is? Sure. So it is a Arduino. I think it's an Arduino Nano, and a carrier board on it that has one of these wonderful SI5351s. Now, the SI5351 is a tiny little chip. You talk to it over a serial port from a microcontroller, and you tell it what frequency of a signal you want it to generate. And it will generate up to 3 signals for you. So it has 3 different VFO outputs, variable frequency oscillator outputs. And so you can tell it, go generate a 4.8 megahertz signal for me, and it will put that out over one of the pins. If you replace the analog VFO on the BITX with this VFO out from the SI5351, you can now use the Arduino to control the frequency that the BITX is receiving on, rather than using the old analog VFO that depends on an inductor and a capacitor to set the oscillation frequency. And those things drift all over the place. If they get a little bit, you blow on it, you can hear it drop in frequency by drop or rise, I'm not sure which. But anyway, it changes frequency by about 1 kilohertz just by blowing on it. So, the old analog ones, they're fun, they drift, but the digital controls are, you get a nice rock solid signal out of it. So the original, just make sure I get this. So the original BITX didn't have a synthesis chip in there to determine the frequency. It was an LC circuit. Correct. And you spin the capacitor to change frequencies, I guess. It's actually a resistor that goes through a diode, and you're using the variable capacitance of a diode based on how much current it's passing. What is that? A varactor. That's what it was. Yeah, so it's a varactor diode. Yeah, so it's a varactor diode tuning, and that circuit is actually still on the board. So the BITX board itself has not changed. So when I say the first version of it, I put that in quotes. The board itself hasn't changed. He just started shipping the Arduino board, the Radduino, as he calls it. He started shipping it with it and raised the price by $10. So it actually started out at $49. The $59 version has the Radduino in it, or not in it, but with it. It's shipped as a separate board in the same box. But you can still put you have to put one component back on the board, and you still can get back at that analog VFO if you want to go back to that old school drifty signal. So on the new version with 2 circuit boards, the smaller of the 2 boards has the LCD display on one side and the SI5351 chip and supporting components on the other side. And there must be some kind of tuning knob, like a pot or something that hooks up to that to tell the microcontroller to slew the SI's frequency up and down?
Yeah, there's some UI. I'll be honest with you, I don't know what it is. It hasn't come out of the little plastic box it comes in on my Workbench yet. I've been working on the first version that I bought. I bought one of the $49 ones. I don't know. There's something about the analog VFO that kind of draws me to it, even with all of its driftiness. There's something about that draws me to it. So I'm building that one first and getting that up and running.
And then you'll be able to modify it with the digital display and the digital tuning.
I could. I probably won't for this one because, like I said, I have two of them.
Mm-hmm.
So I bought the $49 one. I'm probably going to keep it analog. And then I have the $59 one as well. So I'll build a second one that has the digital tuner on it.
So I pulled up the block diagram of this thing at the edge of the circuit board level.
Mm-hmm.
And for those of you listening, if you're still listening there, there's not much to hook up. I mean, all of the components in the board are already soldered on. Yep. The only connections are wires that go to a power supply, antenna, the pot for tuning, speaker, mic, push-to-talk signal,
and a volume pot.
Yeah, I mean, there's if you could put 12 wires on, you could build this thing.
You can absolutely build this thing. I'm going to go out on a limb. I'm going to say Kale can build one of these things. I think we need to get Kale to lead this build project.
Kale,
that's a great idea.
Kale
he
has
keeps talking
one.
about. Oh,
he does.
He?
Yeah, he bought Lord. I think it was almost a year ago. But it's sitting right up there on the shelf next to the antenna analyzer, I believe, as an unbuilt.
Okay. No, we got to get him to build this one because he keeps talking about how he's not all of that, he's not all that technical. And I can respect that from him, but this is one that he can accomplish. And I want to try and encourage him to get this one built.
So one of the things that this thing does not come with is a case. So
Correct.
You get the circuit board and the components and the wires, but you've got to figure out what you're going to stick it in. So one other reason I think this is a great first build project is a lot of people feel really comfortable with things like coming up with the case and doing the wiring, but not the fine soldering and all that. So again, not only a pretty easy kit, but it does give you some creative latitude on how you package it up. So what are you going to do to package yours up?
So the first one that I've started building, I actually had a metal case. It was kind of the two U-shaped folded pieces of steel, like a front, bottom, and back, and then a side, top, and side. The two different U-shaped pieces of metal. I had one of those cases that I don't even remember where I got it. Long time ago. It's been sitting in a parts bin for years, and I looked at it. I'm like, okay, that's about the same size. And I looked at the BITX40. And I placed it in the bottom, and it was perfect. It was exactly the right size. And I'm like, all right, you have found a purpose. And I have some old, M3 computer standoffs that in a junk pile from collections over the years, and I just mounted it into this metal case. I am hoping I just bought a 3 amp hour lithium iron phosphate battery from BioNO Power, and I'm hoping that I have enough space inside the case to kind of strap that to the top of the case so that I can have the battery internal to this box. So it's, just this one box that has the battery and the radio and everything else inside of it.
Oh, nice.
For the digital one, I haven't thought that far ahead yet. I don't know what I'm going to do with that one, but probably something similar.
So one of the interviews, remember, Jeremy, when we were doing some of the What's on Your Workbench listener interviews, one of the interviews we did, and I can't remember the gentleman's name off the top of my head here. I should have written it down. But he built a BitX, and I asked him how he was going to mount it, and he wanted to build it up in kind of a baby man pack kind of configuration. In other words, put it in a box with all the knobs and stuff coming out the end like you have in a typical mobile radio, but do what Mark you just said, put a battery in there and put the antenna connector also on the front face of the radio so that you can stick it in your backpack and all the controls face upward, the mic jack faces upward, and the antenna jack faces upward. So I thought that was a pretty slick idea. I haven't seen his. I'd love to see a picture of his project.
Yeah, that would be cool.
one of the things I did on my BITX, and I'm also doing on the SOAR project that I mentioned earlier, is that I am designing the audio interface to work with cheap gaming headsets that you can buy from your local electronics retailer for about 15, 20, 30 bucks. But the headphones interface is pretty standard. It's a 3.5 millimeter, but it's the quote unquote computer standard electret microphone, also on a 3.5 millimeter, where you've got to give it some voltage and whatnot. But the BITX already does the voltage biasing for that. So if you just hook it up to the right pins on a 3.5 millimeter connector, then you can use gaming headsets, and you don't have to have a separate microphone and a separate headphones. You do still need to rig up a PTT because that's on a separate connector as well. But it's a little easier to do all of that than it is to try and rig up to one of the like dual pin Kenwood style, 3.5 on one side, 2.5 millimeter on the other side, handy mics.
But electrically for the microphone, that would be the same as a computer mic. Correct.
Electrically, it is exactly the same as a computer mic. It's an electret microphone element that you need to give it a DC bias voltage at 10 kilo ohm impedance and blah 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 blah.
So those talking about the different cases and whatnot, those are a lot of I guess we could call them physical hacks. But what are some more of the actual like circuit level hacks that people have done?
So there is do a Google search for BITX hacks. I think it's bitxhacks.com. I don't remember the exact URL, but there is a blog where people post all of the things that they've been doing. Is it Bill from Solder Smoke?
Yes, Bill Miro.
Yeah. Bill posts on that blog a lot because they make all kinds of changes on there. So some ideas. If you watch my YouTube video, you'll understand how the signals flow from the antenna to the microphone and speaker and back in the BITX. One of the things I actually didn't go into in the talk, but is evident when you spend just a little bit of time thinking about it. Very few of the components on the BITX40 are unique to 40 meters. There is one bandpass filter that needs to be swapped out if you want to move this to a different band. So it is very easy, especially if you get one of the bandpass filter modules from Hans Summers, the QRP Labs guy, the guy that makes the Ultimate 3 kit you have, George. He makes these little bandpass filter modules that you can rig into the radio where the existing 40-meter bandpass filter is. And doing that and then adjusting the frequency of your VFO, which is very easy to do when you've got the SI5351 in there, because you just give it a different number over the serial port and boom, it's a different frequency. And you can move the BITX to a different band. You can make it a 20-meter BITX, or you can make it a 60-meter BITX, or an 80-meter BITX, right? And so you can move it around. And if you, if you make those bandpass filter modules swappable, pull out the 40-meter module and stick on the 20-meter module, you can make your BITX multiband, right? Let's see, what are some of the other hacks people have been doing? One of the ideas that I actually had, I haven't seen anyone else talk about, there's RIT, receive incremental tuning, which is a way of saying I'm going to tune my receiver a little bit differently than I tune my transmitter. And so like if you're operating with someone and you're on, the one 1.0 kilohertz or whatever it is, right, on a kilohertz boundary, you kind of want to stay there, but somebody is talking to you and they're a little bit off. You want to be able to tune your receiver to be able to listen to them correctly without affecting your transmit frequency. So that's called receive incremental tuning. I think it's more important on CW, but that's something that you can.
Actually, RIT is used a lot on sideband as well, because if you normally zero in on the other guy's signal and you both sound the same, but sometimes if you don't like the timbre of the audio, you can just move your receiver off 20, 30 hertz and it'll change, without chasing each other up and down the dial. You could just move your receive off a little bit.
Yeah. So RIT is something that you would do that's entirely in software if you've got the Arduino in there. But one of the other ideas that my big radio has, my FT920, has an IF shift. So you can actually shift where the passband, the IF passband is in your audio signal. So normally it's like, 300 to 3000, but you could shift it up so it's 3600 to 3300 or whatever, right? It's not by number, but you can turn that knob up. And if you take one of the other VFO outputs from the SI5351 and use it as the second local oscillator in the BITX, so there's a 12 megahertz fixed frequency oscillator that is the second oscillator into the second mixer on the BITX. Normally that doesn't change at all. But if you want to be able to shift where the IF falls in your receive audio, you can use one of the other variable outputs as that 12 megahertz oscillator and then do some math to figure out exactly how you have to adjust both of the frequencies to get that IF to fall in a different place.
And I assume that the source code for the Arduino is published. I haven't seen that on the website.
I assume so as well. I haven't looked myself, but even if it's not, it is, because you can always download it out of the AT Mega.
Yeah, but it'd be nice to get the source so you could actually read it, understand it.
What, you don't know assembly?
Not for Net Mega, thank you very much. Nor do I ever care to in this lifetime.
Oh, come on. It's a good assembly. Anyway, we'll talk about that later.
Hey, by the way, one thing that struck me too is looking at the website. They do a really, really nice job of breaking those sub-circuits down. So they'll show you, here's the schematic for everything, and then they'll talk about, here's the amplifier and show you just the amplifier's schematic. Here's the diode mixer. Here's the filters. Here's what the filter looks like on a spectrum analyzer, etc. Here's the optional VCO and the schematic for that, the crystal filter. Something so simple as the audio amplifier. So in the schematics, the audio amplifier is the LM386, which is like the cockroach of audio amplifiers.
You can never get rid of them.
They're everywhere, and you can't get rid of them. And they're basically functional. And the reason I mention this is because sometimes you'll look at, especially if you've never looked at the radio circuitry, but you could probably start with the audio amp and look at that and go, oh, I see. Low-level signal goes in here. More signal comes out there. And here's the small number of discrete components, resistors and capacitors, that you need to stick around it to make it work. Now, what's cool about that is you might have some other unrelated project in mind where you need an audio amplifier. You can go back to this reference design and say, I'm just going to take that circuit that I see in the BITX receiver, and I'm just going to replicate the 386 audio amp part by part, and there's a reasonable little audio amp. If you're getting into designing your own radio someday, you'll probably go back to the circuit and pull out the crystal filter or some other sub-circuit. So I think if you kind of really want to kind of dig in to understand a bit more about how this stuff works, at least at that like block level, maybe you don't understand the flow of every electron through the circuit, but at least at kind of a functional level, that these components hooked up in this way does this purpose, then it's really very, very valuable to understand how this stuff is working. So they do a nice job of breaking it down.
I also highly recommend you check out my YouTube video, because that is exactly the level that I went into. I promised my viewers that I was not going to do into any Ohm's law. I wasn't going to do any transistor biasing or anything like that. I'm not going to go down to the component level. I'm keeping this at the block level and showing how things go through. And I think that is a very valuable level and very achievable level for people who don't know electronics. You can still understand. Is if you're willing to let me wave my hands and submit as black magic voodoo that a mixer is a thing. You put in a signal here, we'll call it X, and you put in a signal here, we'll call it Y, that the output of that mixer is two signals, one that is at frequency X plus Y and one that is at frequency X minus Y. How does it do that? No idea. Black magic voodoo. I don't care. Let's take it as a given that that's what it does. If you're willing to accept that, then you can understand the rest of this radio. We don't need to go into the component levels of how that actually works, which is good because honestly, I don't think I could explain it. But if you're willing to accept that as a given, then the rest of the radio makes sense.
Well, this is like back to what Jeremy said a moment ago, that understanding that, seeing that visually, both in the schematic and in the physical world, and maybe with some electrical measurements like with your scope, at that kind of high level, once you get the idea that this is what those signals look like going into the mixer, this is what the signals look like coming out of the mixer as a black box, that's really the first level of understanding, and that's sufficient. You don't even need to know that. But for a lot of us, that you have this thing called a radio, which is a big black box. Then when you dive into it, you go, okay, here's the mixer. That's a little black box. I have no idea how that works inside, but we got some things that go in and some stuff that comes out, and here's the function. And at some point in your ham career, you go, this weekend I'm going to learn how those mixers work. And then you're going to really go read up on how that little subcircuit works. And then you have this like big aha moment with like, holy cow, that's why it does what it does. And by the way, if you're really into it at that level, that is the level of discussion that Bill gets into on the Solder Smoke podcast. And if you want to really understand stuff kind of at that lower level circuitry level, listen to his show. It's awesome because they'll spend like 2 hours talking about how the crystal filter works.
Yeah.
And after it, I always feel like I can't believe I don't understand any of this until then I listen to the podcast. Like, I'm not so sure I understand it now either, but I feel a little bit more educated. So they're a great resource.
Yeah, they are. I started listening to their show within the last year, and I've kind of tempted to go back to the beginning and just catch them all.
You should. I've been listening to Solder Smoke since about episode 10. And it's morphed a bit over the years for a bunch of reasons, but the core of it is always kind of this low level, hardware level understanding of the circuit. And the way Bill describes everything is really quite charming because by his own admission, he's not an electrical engineer by training. And so when you listen to him talk, you think, wow, this guy really knows his stuff. And what you realize is he is an amateur in the true sense. I mean, he's a guy who fell in love with the topic and has become very knowledgeable about it, not because of a formal degree, but because of his dedication and interest in really kind of digging in and having kind of I don't want to say a layman's understanding because he understands it much better than that, but it's
coming from a non-engineering background, he's able to explain it to non-engineers.
Exactly. Yeah. And by the way, so this is like the plug for Solder Smoke, isn't it? One last thing. He wrote a book that's really cool that is about his personal journey in learning about radio electronics and some of his own personal life. And I don't know if it's still in print, but it used to be available as a download or a print copy from lulu.com. Mm-hmm. And it's like it's on his website. It's Solder Smoke, an adventure in radio or something like that. And it's really fun because it's sort of like his personal story, which is quite interesting because he works for the State Department as a diplomat. So it's his kind of experiences with a lot of here's how I learned how a product detector works. So I think for us hams, it's like, and then we snap back into the circuitry, which is really fun. Anyway, so
I'll add that book is still available from Amazon. It's actually, it looks like it's free. It's $4.99 on Kindle. Unless you are a Kindle Unlimited member, then it's free. The paperback book is available for $5.54, and we'll have links to both those in the show notes. Also, as you guys have been chatting, I've been actually exploring the BITX Hacks website, which is holy cow.
I know, right?
I mean, what did you find?
I'm just waiting to find the circuit where somebody just ripped out the PAs from the power transistors off the board and hooked it up to some valves. I mean, like literally so many little tweaks and so many things from, again, little physical modifications to, putting in sophisticated audio filter. I mean, it's pretty cool. And George, yes, the source code is available for download. So online, one of the biggest support areas for this thing used to be a Yahoo group called the BITX40 Yahoo group, which oddly enough was started and run by Hans Summers. And they recently... they're buds. Like that's actually my biggest... my biggest disappointment at Hamvention was not getting to talk to Farhan or Hans, because they were both there.
I didn't know that he was there too.
Yes, he was. Yep, they were both there because that's another thing. Like the Smitty, after you talked about the Ultimate S3, like that's another thing that I'm very interested in building. The only reason I honestly haven't invested in that is because I can't put a wire up outside to do the whisper stuff. But
yeah, okay, not even like a long wire run through some trees.
Yeah, I live in an antenna restricted neighborhood, and I have one neighbor who pays attention.
Do you have a fence line?
Negative, Ghost Rider. I have like 100. I have 100-foot hickory in my backyard. Yeah, a flagpole. The only problem with the flagpole is there is a tree in the center of my front yard. I mean, this is like pretty average suburban, like 0.2 acre lot.
Stealthy 26 gauge black stealthy wire.
I could try.
Thrown up in the tree.
I could try.
You'd be surprised how well that would work. I got just the matching unit for you.
Well, I think I have one or two of those in my basement.
I bet you do.
Actually, well, funnily enough, I was originally planning on taking a bunch of Pactenna stuff out for field day until I found out it was QRP, and it's like, well, okay, so now it's just the full-size Pactenna because you want resonant antennas. Although they're talking about running everything off ladder lines for the dipoles, which is probably a good idea.
There was some stuff on the HF6 website as well? I mean, obviously there's manuals and that sort of thing there, but...
On that website, which obviously is where you order the thing from, they have an overall breakdown of the kind of like block level theory of the circuit. But I did not find a link there to the Arduino source code. I did find that on the Google.io or the groups.io BITX40 group, which I will make sure we have a link to in the show notes.
Perfect.
Very good. Well, I think at this point we should probably take a quick break and come back in a couple minutes here and get ready to wrap. What do you say?
Sounds good.
All right, we'll be right back after this. This episode of The Workbench is brought to you by Autodesk Eagle PCB Design Tools. All of our projects we're doing on the Workbench use Eagle. It's great for schematic capture and board layout. You can easily generate all of the output files necessary to manufacture a circuit board. And whether you're building one board or 100 boards for your friends, use Eagle tools because they have really excellent support. They've got a great library of available components. It's widely used amongst the maker and the professional board design tool. You'll enjoy using the tools, and there's a lot of great new features. Check it out at autodesk.com/eagle, and you could download a free copy of the PCB design tool today and get started doing your project. So, Mark, while we were talking about some of the unique features of the BITX40, one of the things that you were talking about is how in a traditional radio you've got a receive chain, and those electronic components are almost entirely separate from the transmit chain. But in the BITX40, they actually share some components. Could you describe that a little bit for us?
Yeah, absolutely. So one of the brilliant things that Farhan did with this radio, and I don't think it's unique to Farhan. I think people have been doing this for a while. Homebrewers have been doing this for a while. But one of the absolute brilliant things about this radio is that it uses a lot of the same blocks. If you look at the chain of blocks that you need to put together for a transmitter and the chain of blocks you need to put together for a receiver, they are nearly identical, but in reverse order, right? So you got the antenna at one side and a microphone and a speaker at the other side. And the chain in between, it's roughly, if you ignore the power amp, because that's pretty much transmit only, but, coming from the antenna towards the user, you have like, a bandpass filter, and then you've got a mixer, and then you've got a amplifier, which we do have to make bidirectional, which we'll go into details in my video. And then you have the crystal filter, and then you have another amplifier, and then you have another mixer, and then you go into the audio processing stuff. And all of those blocks are used on both transmit and receive. The transmitter goes from the microphone to an amplifier to the mixer to the crystal filter, blah, 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 blah. But on the receiver side, coming from the antenna, goes from the crystal filter to the mixer to the audio amplifier, right? So it goes the other direction. And so the really cool thing about this is that with the exception of the bidirectional amplifiers, which I'll go to in a second here, everything is used in both directions. The filters are bidirectional. The mixers are bidirectional. The antenna is obviously bidirectional. bidirectional. Really, the only thing that needs to be a transmit one and a receive one are these amplifiers that you have at various different points in the stage. And the amplifiers themselves are exactly the same circuit. You have one pointing to the right, that is a receive amplifier, and one pointing to the left, that is a transmit amplifier. And so I was talking earlier about the blocks, how there's like this rectangular block on the board, and you look at it, you say, oh, there are 3 of these blocks that are all identical. And then if you look inside one of those blocks, it's even a kind of a mirror image of itself. One of them is the transmit amplifier and one of them is the receive amplifier. But you have these 2 amplifiers that are in parallel with each other. The output of one is the input to the other, and that common node is tied to, maybe the filter on that side. And then the input to the first one is tied to the output of the second one, which is tied to the mixer on the next stage or whatever. And you choose which amplifier is being used by powering one or the other. And these amplifiers have to be designed in such a way that when they are not powered, they do not affect the circuit. They just have to be high impedance when they're not actually being powered. And that is, a design consideration to put into these amplifiers, but that's what they did. And so your push-to-talk is literally just a switch that says, am I applying 12 volts to the receive power line or the transmit power line? And when you push it, it energizes all the transmit amps and de-energizes all of the receive amps, and that turns it into a transmitter. And then when you release the push-to-talk, it de-energizes all of the transmit amps and energizes all of the receive amps, and that turns everything into a receiver.
So the advantage of that is it reduces component count. It reduces the number of parts, thus the cost in
Correct.
the circuit, right? So, well, I guess it could also maybe even save on power consumption.
Well, sure.
Because you don't have parts that are on but not being used in the other mode, transmit or receive.
Yeah, true. But really, I think it's more an economy of stuff, right? Economy of parts, because the crystal filter is kind of one. Amplifiers are amplifiers, right? They're the same amplifier anywhere you put it in the system, at least by this design. But the crystal filter is kind of the one part or the one block that is used differently in each direction. On the transmit side, the crystal filter is used to select which sideband you're going to transmit, whether you're transmitting the upper sideband or the lower sideband. The output of that mixer you take the microphone audio in on one side, you take your local oscillator in on the other side, you mix those together, and what you end up with is a positive image of your microphone audio above your oscillator frequency and a negative image of your microphone audio below your oscillator frequency. One of these is an upper sideband. The higher one is an upper sideband and the lower one is a lower sideband, but they're right next to each other, right? They're only separated by a few hundred hertz, and that's only because you rolled off below 300 hertz on your microphone. So everything below 300 hertz is rolled off. So your upper sideband starts 300 hertz above the frequency of your local oscillator, and your lower sideband starts 300 hertz below the frequency of your local oscillator. So you've got the 600 hertz window where you need to filter off one of the sidebands but pass the other sideband. And so the crystal filter is a very narrow bandpass filter that passes one or the other of these. And so that's how it's used on transmit. On receive, you've got this giant swath of RF energy coming in. At this point in the signal chain, it's about 300 kilohertz wide because it's however wide your bandpass filter was earlier in the chain. So you've got 300 kilohertz of RF energy coming in to this filter, but you only want to listen to that one single sideband session. So you need selectivity, right? So the term the receiver term for this is selectivity. How selective is my receiver? Am I listening to just the one signal that I wanted to hear, or am I also hearing nearby signals above this frequency or below this frequency? It's especially critical you don't hear anything below the frequency because that will get imaged up into your audio range when you mix it back down again. So it's very critical that you correctly filter off everything below the frequency that you're looking to receive because that just does bad things to your audio. The frequencies that are above what you're trying to receive, they just end up as high frequency audio stuff. But you can filter that out in audio at the audio level if you wanted to. You cannot filter out things that are below your signal.
So go ahead. No, please.
Oh, I was just going to say, so this crystal filter is doing two different things depending on whether it's in the transmit path or in the receive path, but it's the same physical design of a circuit.
So I was just thinking that when we were talking about learning the basics of the blocks in the radio, in the receiver, and in the transmitter, looking at the subcircuits is useful. But you're bringing up a really interesting macro level point, more of a system design issue, which is if you need all these stages in the receiver and transmitter, and you set out to minimize the component count and the size and the power consumption by reutilizing certain subcircuits in both receive and transmit, then that's a whole nother layer of like circuit optimization. It's an interesting problem to think about. I mean, that in a way that's a much more sophisticated design approach than it is to say, okay, I'm going to lay down all the receiver parts here, then I'm going to lay down all the transmitter parts there, and I'm going to put a TR switch in between them.
He's brilliant, isn't he?
Yeah, I mean it's very subtle. You wouldn't realize it unless you really looked at it like you have to really understand the nuance in the design of the circuit. It's really quite clever.
Yeah, the description that I just gave is a very audible one. You know, I didn't have the visual aids in front of me. If this sounds interesting to you, I really recommend you go check out my YouTube video and let me know whether you like it, whether it worked for you or not. This is the first kind of video that I've done like that, where I've taken a topic ahead of time and actually planned what I'm going to do in my video, as opposed to just hitting go and streaming.
So while we're on the videos, what other videos have you done on other topics?
Oh, geez. Okay, so I call my YouTube channel an accidental YouTube channel. Excuse me. A couple of years ago, I was working on a circuit. I don't even remember which circuit it was at this point. And I wanted to do a Google Hangout and screen share and have some friends of mine from Twitter join me in the Google Hangout just to chat about the circuit that I'm working on, to ask me questions, to peanut gallery, right? To ask me questions, to point out mistakes that I made, make recommendations, whatever. Just, to kind of do something like an interactive circuit layout. And when I did the Hangouts, I accidentally clicked the button that said Hangouts on Air. And at the time, Hangouts on Air was basically, all right, you're going to go do a Hangout just like a normal Google Hangout, but we're going to record the video. And we're going to make it available on YouTube when it's done. And so I did this Hangout. I think it was like an hour and a half long or whatever. I don't even think anyone showed up. So it was me just staring at the camera, not even talking. It was a really bad video. But at the end, it said, it's like, all right, here's the link to your YouTube video. And I'm like, a what? I did a what? And so I literally had this accidental YouTube channel. And I'm like, okay, well, I tweeted about it. And lo and behold, I started getting views. People started watching me, and it surprised the heck out of me. I wasn't expecting it. And I'm like, all right, well, let's do this for real. And so I started using OBS, which is the open broadcast system. So I have a little picture-in-picture. There's a webcam pointing at me while I'm doing a screen share on my circuits. And I've kind of gotten this little following of between 2 and 5 people, maybe 10 people who show up and watch me lay out circuits, and they'll interact with me. I've even gotten to the point where I'm trying to get the video from the chat room on the screen while I'm doing my layout, so viewers can see what it is that that I'm interacting with, or who it is that I'm interacting with, and what their comments are. And I've done, I think, 50 or 60 videos at this point. Usually I'll put them in playlists based on what the project is that I'm working on. If you're curious about whether this is actually worth watching, the one that I would start with is my wall clock, WOL clock, because it's a single video. It's 2 hours long, which seems long, but I start with a blank page, like a blank schematic. I explain what it is I'm trying to accomplish, and I go schematic layout all the way over to component selection, board layout, and by the end of that 2 hour video, I am placing an order on Osh Park. So that is a really good video as a kind of just a start to finish what it is to lay out a circuit board. And that's kind of where I recommend people start out if you're interested in trying out my channel.
So that sounds like a great idea. Jeremy and I have been talking about doing a very similar thing where we do a video and do a walkthrough from start to finish on a simple board. So we're planning to do something like that. So I'll definitely check it out and see how you did yours. And I'm very curious about the software you used to produce it. So we'll have to check that out.
Okay, yeah, we'll chat afterwards.
All right, very good. Jeremy, anything else you want to add to the BITX discussion?
No, not really. I mean, again, this is certainly a much better project than we could have come up with. Because, I mean, in the beginning, George and I did have a long conversation about potentially trying to do a radio kit of some kind. And George basically was like, don't have the time and don't feel like I can offer anything that somebody else hasn't already done better. And this is a screaming example of that. So, just want to remind folks that if you're interested in kind of, staying loosely connected on this, go ahead and start ordering your kits now. I noticed that there are two options for shipping on the site. There's you pay the $59, it shows up when it shows up. But then there's also pay a $10 premium and DHL will have it to you in like a week to 10 days.
Oh, when I ordered mine, I don't think it took more than a week to 10 days. Maybe 2 weeks, but yeah.
All right, so
I think mine the same way. I think it took maybe 2 weeks to get it the regular way.
Cool.
Yeah.
So, I mean, it sounds like this thing offers a lot of opportunity to kind of spark the imagination, which is always good. And I'm just looking forward to getting one and trying to play with it. Actually, in hindsight, I kind of wish I would have known or would have paid more attention to this to try to do it before field day.
You're going to be busy with that 5-element beam in your 5-watt amplifier.
I won't be. I will not be busy with that. That's other people because there's like climbing and height involved, and that's I will be. I'm actually really hoping to do a video of field day this year. I used to religiously do field day videos whenever I did field day, and then the last couple of years I just haven't. But I'd really like to bring that back again this year.
Well, hopefully we might do a little bit ourselves. I do want to mention a couple of quick things relevant to the BITX before we wrap off this topic. One is I mentioned earlier that one of the interviews we did a while back, there was a guy who did a BITX build in a custom case, and that was back in episode 20, which when I think about it, 20 doesn't seem like that long ago, but it feels like a long time ago. So that was the Listener Project's episode, the second of the two. And that gentleman is Don, Kilo Golf 5 India Whiskey Lima, KG5IWL, who we happened to catch just when he was moving states, actually. He was kind enough to carve out time to talk about it. So Don's the guy who built the custom man pack kind of case. So if Don's listening, we'd love to hear from you, see how it went, maybe get some pictures to put on the Facebook or the web page. And the other thing I wanted to mention is that I've been talking with the guys from Autodesk, the Eagle guys, and they do webinars on their website for Eagle, and they invited us to participate in one of their webinars. So in the next couple of weeks, we'll be doing a 1-hour webinar with Autodesk, and the circuit that we're going to feature is the DC power control circuit.
Oh, nice.
So we're going to talk all about how a hobbyist would approach doing a design with Eagle, about this particular application that's useful not only for ham radio projects but for anybody who wants to do preparation for the next zombie apocalypse or whatever 12-volt project you've got. And we learned a few interesting things about picking transistors and thickness of copper and stuff like that for power circuitry. So we're going to record that webinar in a couple weeks, and we'll announce on the Facebook page if you want to watch it live, and if you want to watch it recorded, it'll be up on their website. So check that out in a couple weeks.
So you said the next zombie apocalypse. When was the previous one?
Good question.
Okay, just curious.
All right, the first zombie apocalypse.
All right, there we go.
Very good.
I should have something snarky for this, but that's how tired I am.
It's been a long week, man. All right. Hey, Mark, thank you so much for spending your time and for sharing and just taking the time to make the videos and everything. That's just a super service. So thank you for everybody.
You're very welcome.
And go ahead.
I was going to say, thank you for having me on. I really enjoy coming on with you guys. This is a real blast for me. So thank you. So
Mark, real quickly, if folks are dying to rid themselves of $60 to $70, where do they go online to buy one of these again?
hfsigs.com. HFSIGS as in hfsignals.com.
Roger that. And if they want to go watch you build many things but never finish them, where do they go?
YouTube, do a search for Smitty Halibut, SMITTY HALIBUT. That's also where you can find me on Twitter, at Smitty Halibut.
And if they, well, I was about to say, you beat me to it.
Sorry.
If they, no, it's fine. I was going to say if they want to engage in witty banter with you, but you've already addressed that.
Peanut Gallery, bring it on.
There we go. That's right. I've been a member of the Peanut Gallery a few times, and I have greatly enjoyed it. In fact, actually, you inspired me to stream the time that as I was working on my 3D printer build.
Yeah. That was good. That was fun.
What's hilarious is, as you were talking about how you were surprised that people were watching, and I just went and looked, because in the first week there were like the 6 people that watched it, and it's up to like over 700 views.
Oh my God! None of my videos have that many views. I think my biggest video right now is I got mentioned by Chris Gamble of Contextual Electronics once, where he just tweeted. He said, "I'm just watching this guy lay out circuit boards. It's very zen," and I think that video got like 250 views.
This is, in all fairness, a bit of a niche.
Yes, it is. It is very niche. This is not a moneymaker. This is not. I'm not trying to promote myself or anything like that. Right. I just do it because I like having the peanut gallery while I'm working on things. And if people are learning stuff from me doing it, then that's absolutely worth it.
Speaking of the peanut gallery, maybe if when you were laying out boards, you had a couple of goats wandering around in the background,
like Peanut.
And Rooster,
yeah.
Although one of those guys is gone.
I think it was Peanut.
Yeah, you have no idea what we're talking about, do you, Mark?
No, I don't.
So the reason I started my YouTube channel is there is a ham out there whose name is Steve. His call sign is Whiskey Golf Zero Alpha Tango.
Okay, yeah, the goat guy.
Yes.
He goes on hikes and does QRP on hilltops with goats.
Yep.
I've seen a couple of his
except
videos.
In Colorado, I think they call them mountains.
Mountains, yeah. Well, yeah, they are rather large out there. I have stepped on my cat's tail once. That was exciting. Like while on video, while streaming. That was, yeah.
All right, George, I think that'll about do it for this week.
I think so, Jeremy. Hey, thanks again, Mark. It's been a pleasure.
Absolutely.
Thank you, guys. I really appreciate it.
Folks, as always, if you have comments, questions, or feedback, please feel free to reach out to us via email at workbench@hamradio360.com. For more information about our show and our flagship show, the Ham Radio 360 Workbench podcast, you can search for Ham Radio 360 in your favorite podcast player, or you can go to hamradio360.com. Have a wonderful week. If you would like to get a hold of me, I troll Twitter. You can follow me at KF7IJZ.
And I'm George at hamradio360.com or at KJ6VU on Twitter.
And George is also the one who pays more attention to Facebook than I am. Remember, next week we are back with another exciting episode of Ham Radio 360, which we're getting close to episode 100 over there.
Woohoo!
Yeah, pretty exciting.
Yay.
Anyway, everybody, thank you very much. Don't be afraid to pick up a soldering iron and 73.
Happy Field Day, 73.
Be good humans, everyone.
Recording now. Me. All right, ready?
Yes.
Okay, 37 minutes. That's actually not bad. Perfect. The girl from Ipanema.
The Ham Radio Workbench podcast is brought to you by my friends down at the Main Trading Company.
Not this show. That's the other show.
What's worse is that I just realized halfway through that's probably going to the blooper reel. Smitty tries to impersonate Kale, making a horribly offensive attempt at it.
Your
Kale.
blooper reel will be one continual 1,000 cycle tone.
Boo.